The way the right-hand cross product rule works is you have to use your right pointer finger as well as your middle finger and your thumb as well. That's all we need for it. The other fingers can simply be tucked in here. Okay. It's important when using this rule we need 90 degrees between these appendages or digits. Okay, so that's very important. Make sure that you have right angles between them. And you want to hold that position locked as you move your arm and elbow around in order to use the right hand rule. This is called the right hand cross product rule. Okay. Now, what the cross product rule says is that anytime you have a cross product of vector A crossed with vector B, then you can point your pointer finger in the direction of vector A, the first vector in the cross product, and then point your middle finger in the direction of B, which is the second vector in the cross product. Then your thumb points in the direction of the result, A cross B. It's not commutative, which means that the fingers have to be in order. The first one in your cross product has to be the pointer, and the next one that's listed has to be the middle. So B cross A is not the same as A cross B. All right, so what does this have to do with our problem? Well, our problem said that if you have a piece of paper here, let's say, and you have a current carrying wire that's going through that plane, we can tell that it's going through because there's an X. And let's say we want to evaluate the magnetic field here at point A. We can use the cross product rule to determine what the direction of the magnetic field will be at point A. So here's how it works. We're going to use a formula, B hat equals V hat cross R hat. Now these are unit vectors, which means they have no magnitude, only direction. Okay, and this is going to be something that we'll use quite a bit. We're going to use this quite a bit in the next few videos as well. So what do we mean by V hat? We mean the direction of current. Or in other words, the direction of positive charge. All right, so since we have an X for our wire, that means that current is flowing into the page. And if current is flowing into the page, then that is the direction of V hat, into the page. Because conventional current is, of course, describing the motion of positive charges. Okay. So what is R hat? that is going to be a radial unit vector pointing away from the wire. So r hat points toward point A. It's directed toward the point where you're evaluating the field. And A is, of course, the point of evaluation. All right, so what we want to do is we want to move our right arm and elbow, if possible, into a state where our pointer finger points in the direction of V hat and our middle finger points in the direction of R hat. Then our thumb will tell us the resulting direction of the magnetic field. All right, so if I can draw what I'm talking about here, I'm talking about letting your pointer finger point down in the direction of V hat. But you have to twist your body so that your middle finger will now point this way, which is in the direction of R hat. Okay, and then your thumb is going to tell us the resulting direction of the B field. The thumb tells us the result. Okay, so just to be clear, this is the pointer. This one's the middle. And this one's the thumb. Now the other fingers, they can just kind of be curled up here for now. And this is just the rest of the wrist here. Okay. The result is the direction of the magnetic field. And if you think back to how we had determined the direction before, you'll see that it is in agreement with the right-hand rule. See if you can point your hand in that way and see how the thumb points in the same direction as my B field. So if we go back for a minute to the two-dimensional problem that we were given, we're just looking from a bird's eye view now of our wire from the top down. There's point A. There was the wire carrying 5 amps. That was the current. Oftentimes we're going to want to give the direction of our field in terms of unit vectors I, J, and K. So in many problems you'll be given a positive X direction and a positive Y direction for reference, and a positive Z direction will be included as well. All right, so when it comes to unit vectors, I hat is going to be to the right, J hat is up, and K hat is out of the page. So you may be asked, what is the direction of the magnetic field at point A? And you have to give your answer in terms of I, J, or K. All right, so since we determined that the field points directly downward, then that means that the direction of the magnetic field at point A is going to be negative y or negative j, it'll sometimes be called. Okay, and it's all relative to that given coordinate system.